This video is about the geometric mean theorem. Consider the following right-angled triangle ABC with edge lengths A, B and C, and the altitude belonging to AB, which is the altitude CD, is called H, and the lengths from D to A and from D to B is P and Q respectively. Then the geometric mean theorem says that the square of the height H is equal to the multiplication of P and Q, or that H is equal to the square root of P and Q. To illustrate how we use this method, we use the following example. We have right-angled triangle ABC, and we want to calculate the area of this triangle. In order to calculate the area, we need at least a base and a altitude, so AB and AC would suffice, but also AD and BC, with BC being the base and AD the altitude belonging to that. In order to calculate the base BC, we're going to use this geometric mean theorem, and we're going to write it down first. Let's look at the geometric mean theorem. The H in the theorem is the altitude belonging to the hypotenuse. In this case, because A is the right triangle, BD is the hypotenuse, so the altitude belonging to that is AD. So AD squared is equal to these two line segments of the hypotenuse multiplied together, so that's in this case BD and CD. Well, AD we know that's 4, so AD squared is 4 squared, but both BD and CD are still unknown. So before we can calculate that, we need to calculate at least one of these two line segments, BD or DC. Fortunately, ABD is also a right-angled triangle, so we can use the Pythagoras theorem in this triangle ABD. Pythagoras' theorem says that AD squared plus BD squared is AB squared. Since BD squared is our unknown, we isolate that, and we do that by subtracting AD from both sides, so BD squared is AB squared minus AD squared. AB squared is 25, because 5 squared is 25, and AD squared is 16, and 25 minus 16 is 9, which gives that BD is equal to the square root of 9, or 3. So we know that BD is 3, and then we can write down 4 squared, 16 is BD, 3 times CD, our only unknown left. Now, that gives that CD is 16 divided by 3, or 5 over 1/3. So we calculated CD 5/1/3, and we can calculate the area as the final step, which is a half times a base 5/1/3 plus 3 is 8/1/3 times its matching altitude 4, and if we calculate it, we get 16/2/3. So the trick to examples like these, questions like these, is find out as much as you can and use the correct theorem. In this case, Pythagoras' theorem for calculating BD, and then the geometric mean theorem for calculating CD.